Okay, you are welcome to this my second video in physics. This is the continuation of the last my previous video on force, and I want us to solve this problem which we have on the board. Okay, a car of mass 12, 1,200 kg traveled at 72 kilometers per hour is brought to rest in 4 seconds. A car of mass 1,200 kg traveled at 72 kilometers per hour is brought to rest in 4 seconds. Find A, the deceleration, B, braking force, C, distance moved during deceleration. Distance moved during the deceleration. Okay, so here we go. That is the question, and we now want to start the solutions now. The solutions. Okay, so solutions. A. We are calculating the deceleration. We are calculating the deceleration. We know that if we collect the data of the question, it was, or rather, it is saying the mass. The mass equals 1,200 kg. That is the mass, and then it traveled at 72 kilometers per hour. That one will be, in this case, our velocity. Okay, our velocity v. In fact, that one is not just our velocity, but it is our initial velocity, which is denoted by letter U, 72 kilometers per hour. And then we also, the time, it is equal to 4 seconds. 4 seconds. And then apart from that, the question was saying, a car of mass 1,200 kg traveled at 72 kilometers per hour is brought to rest, which means our final velocity v will be equal to 0. If it will be 0. If an object is moving at a certain velocity, and then it is brought to 0, that our final velocity, it is brought to rest, our final velocity, it will be 0, and that speed which that specific object is moving at that particular time, it will be your initial velocity. Always that which comes later after the first given velocity, or rather the speed, it becomes your final velocity. Okay, so in this case, the car was moving at 72 kilometers per hour. That is our initial velocity. Then finally, it was brought to rest. That is our final velocity, which is a 0. So this is our data. We have collected our data like that. Then the question is saying calculate the deceleration. So deceleration, the formula that we are going to use for calculating deceleration, it is the same formula that is usually used to calculate acceleration. The difference is that when we find the answer for deceleration, it will give us the negative answer. The answer will be negative. That is the only difference, but the formula is always the same. What is our formula? Our formula is v, which is our final velocity, minus u, our initial velocity, over time. That is the formula for our acceleration. In this case, we are calculating deceleration using the same formula for acceleration. Therefore, we are going to say this is equals, what is our v? We come on the delta, v is 0. Our final velocity minus, what was our initial velocity? It was 72 kilometers. Now, we cannot use 72 kilometers per hour when the time is given in seconds. This will force us to convert 72 kilometers per hour into meters per second. 72 kilometers per second into meters per second, because the time has been given in seconds. If the time was given in hours, we were going to say, okay, fine, our velocity can still be in what? Our velocity can still be in kilometers per hour. Therefore, to convert 72 kilometers per hour, we are going to multiply 72 times 5 over 18. This is the formula for converting this. This is what you multiply any given number in kilometers per hour, converting it into meters per second. It is 5 over what? 5 over 18. And if you calculate 72 times 5 over 18, the answer that is going to give us is 20. This 20 will be in meters per second. Therefore, we are not going to write this 72 here because it is in kilometers per hour. Therefore, we are going to write the 20, which is in what? Meters per second. That will be our final velocity. So we are going to use the 20 here. Over, what is our time? The 4 seconds which we have been given. Okay. Therefore, we will say this is equal to 0 minus 20. It is negative 20 over 4. Okay. 4 into 20, it will give us negative 5. Okay. This will be in meters per second squared. That is our deceleration. The units, the SI units for deceleration are the same units which we can use for acceleration, just that the answer is in negative form as it is deceleration. Deceleration means reducing the speed. As we saw in the question that the car was moving at 72 kilometers per hour and then it reduced its speed to zero. It went up to rest. It is stopped. Okay, therefore, by reducing the speed, we'll be forced to find the deceleration. By increasing the speed, we'll be forcing to find the acceleration. Therefore, we use the same formula. That is our acceleration. Oh, our deceleration. Sorry, our deceleration. Okay, that is our part A. Now we go on B. We go on part B, we find the braking force. Okay, we have to calculate the braking force. The braking force. B. The braking force. So I'm going to say, when they say braking force, it's just the way of confusing you in an exam, but what they're just talking about is you to calculate the force. So force is equal to mass times acceleration. Okay, therefore we're going to say equals mass. Our mass, if at all we have to correct the data again, we were told that the mass was 1,200 kg. Then our acceleration. Now in this case, we are going to use our deceleration to find our acceleration. So our deceleration was -5. Therefore, in this case, our acceleration will be 5. That same deceleration we found there, in this case, if we have to turn it into acceleration, we are just going to remove the negative there in order for it to be the acceleration. It's the same, just that it shouldn't have the negative sign. So I'm going to say mass, it is 1,200 times 5. 1,200 times 5, we are going to get 6,000 newtons. 6,000 newtons. 6,000 newtons. That is our force. We go on part C. Okay, we go on part C. We go on part C, which is generally talking about the distance. The distance. The distance. Part C is talking about the distance. Okay, the distance. The formula for calculating distance is distance equals speed times time. Speed times time. That is the formula for calculating the distance. Distance equals speed times time. Now, we want to calculate the distance which was covered, or which was traveled during the deceleration. During the deceleration, as the car was reducing the speed from 72 kilometers per hour, as it reduced the speed in 4 seconds, okay, to what? To 0, which is resting. Okay, for the car to have stopped moving, what was the distance which was covered? Therefore, we say distance equals speed times time. So we're going to say distance equals our speed. Now, if we have to correct the data again, okay, we are saying mass was 1,200. Our acceleration was found. We said it was 5, which was in fact our deceleration. We can say -5. Acceleration will be 5. And then we were also given the time to be 4 seconds. And the speed. In this case, the speed is going to be we're going to use our initial velocity. We are going to use our initial velocity that the car was running at. And our initial velocity was 72 kilometers per hour. That 72 kilometers per hour, we converted it into 20 seconds. Sorry, 20 meters per second. So that is what we are going to use. So distance equals our speed will be 20 times our time is 4. Therefore, distance will be equals 20 times 4. Sure, it will give us 400 kilometers. 20 times 4. Oh, it's 80. Sorry. 80 meters